Unit 4, Lesson 1, Number Puzzles. Number 1. Tyler reads 2/15 of a book on Monday, 1/3 of it on Tuesday, 2/9 of it on Wednesday, and 3/4 of the remainder on Thursday. If he still has 14 pages left to read on Friday, how many pages are there in the book? If 3/4 of the remainder was read, then 1/4 of the remainder is 14 pages. Then 4/4, the whole remainder, is 14 pages times 4, or 56 pages. The whole remainder is 56 pages. 2/15 plus 1/3 plus 2/9 equals 31/45 times B, or the whole book. 45/45 represents the whole book, minus 31/45, the pages read, and that equals the remaining pages to be read, or the remainder. 45/45 minus 31/45 is 14/45. 14/45 times B equals 56. To solve this, we have to get B alone. So 14/45 divided by 14/45 equals 1, and 1 times B equals B. And 56 divided by 14/45 equals 180. So B equals 180. The book has a total of 180 pages. Number 2. Claire asks Andre to play the following number puzzle. Pick a number, add 2, multiply by 3, subtract 7, add your original number. Andre's final result is 27. Which number did he start with? Pick a number, add 2, multiply by 3, subtract 7, add your original number. 3 times x is 3x, plus 3 times 2, which is 6, minus 7, plus x. Let's combine the x's. 3x plus x is 4x, and now 6 minus 7 is -1. Well, Andre's final number was 27, so we know that 4x minus 1 equals 27. Now all we have to do is solve for x. Add 1 to both sides, and we have 4x equals 28. 4x divided by 4 equals 1x, or x, and 28 divided by 4 equals 7. X equals 7. Andre's original number was 7. Number 3. In a basketball game, Elena scores twice as many points as Tyler. Tyler scores 4 points fewer than Noah, and Noah scores 3 times as many points as Mai. If Mai scores 5 points, how many points did Elena score? Explain your reasoning. I've decided to make a table. Elena scores twice as many points as Tyler, or 2 times t, and Tyler scores 4 fewer points than Noah, or n minus 4. Noah scores 3 times as many points as Mai, or 3 times m. And Mai scores 5 points. Well, if Mai scores 5 points, then Noah scores 3 times 5, which is 15. If Noah scored 15, then Tyler scores 4 less than that, or 15 minus 4, which is 11. And Elena scores 2 times the amount of points that Tyler scored. And 11 times 2 is 22. So Elena scored 22 points. Number 4. Select all the given points in the coordinate plane that lie on the graph of the linear equation. (4x minus y equals 3). A. Points -1 and -7. -1 is the x value and -7 is the y value. So 4 times -1 is -4 minus a -7. Minus the -7 is like the opposite of a -7, which is a +7. So -4 plus 7 equals 3. Yes, this point would lie on the graph of the linear equation. B. points 0 and 3. 0 is the x value and 3 is the y value. 4 times 0 equals 0, and 0 minus 3 equals negative 3. And negative 3 is not equal to 3, so this is a no. C. Points 3/4 and 0. 3/4 is the x value and 0 is the y value. So 4 times 3/4 minus 0. 4 times 3/4 is equal to 3, and 3 minus 0 is 3. 3 is equal to 3, so this would be a yes. D. Points 1 and 1. So 4 times 1 minus 1. 4 times 1 is 4, and 4 minus 1 is 3. And 3 is equal to 3, so this is a yes. E. Points 2 and 5. 4 times 2 minus 5. 4 times 2 is 8. 8 minus 5 is 3. And 3 is equal to 3, so this is a yes. F. Points 4 and negative 1. 4 times 4 minus a negative 1. 4 times 4 is 16. Minus a negative 1 is adding 1. So 16 plus 1 is 17. 17 is not equal to 3, so this is a no. Number 5. A store is designing the space for rows of nested shopping carts. Each row has a starting cart that is 4 feet long, followed by the nested carts. So 0 nested carts means there's just one starting cart. The store measured a row of 13 nested carts to be 23 5/10 feet long, and a row of 18 nested carts to be 31 feet long. A. Create a graph of the situation. The y-axis is feet long, and the x-axis is number of nested carts. I counted by 2s while making my graph. One point on the graph needs to be at 0 and 4, and another point on the graph needs to be at 13 and 23.5. You would want to use a ruler to connect the points to get a line as straight as possible. B. How much does each nested cart add to the length of the row? Explain your reasoning. I found the slope. The slope is up 3 and over 2. So the slope is 3/2 or 1.5. That's equal to 1 5/10 over 1. And that means that one cart adds 1 5/10 feet in length, or 1.5 feet in length. C. If the store design allows for 43 feet for each row, how many total carts fit in a row? 43 feet minus 4 feet. The 4 feet represents the first cart, or the starting cart. 43 minus 4 is 39. 39 feet divided by 1 5/10 feet, or 1.5 feet. The 1.5 feet is for each of the rest of the carts. And 39 divided by 1.5 is 27. So with 43 feet in each row, you could fit 27 carts total. 8th grade, Unit 4, Lesson 2, Keeping the Equation Balanced. Learning targets. I can add or remove blocks from a hanger and keep the hanger balanced. I can represent balanced hangers with equations. Problem number 1. Which of the changes would keep the hanger in balance? Select all that apply. A. Adding 2 circles on the left and a square on the right. To make this easier, let's give these shapes imaginary values. Let's pretend that the triangles are worth 5, the circles are worth 1, and the squares are worth 2. If we add a square to the right and 2 circles on the left, we'd be adding the same amount to both sides. We'd be adding 2 to the right and 2 to the left. This would remain in balance because each side would total 9. The answer for A is balanced. B. Adding 2 triangles to each side. If we added 2 triangles to each side, we'd be adding the exact same amount on each side. 2 triangles would be worth a total of 10, so we'd be adding 10 to the right and 10 to the left. The left side totals 17, and the right side totals 17, so this hanger would also be balanced. C. Adding 2 circles on the right and a square on the left. If we added 2 circles on the right, that would be like adding 2, and if we added a square on the left, that would also be adding 2. So we'd be adding 2 to both sides. The left side totals 9 and the right side totals 9. So this hanger would also be balanced. D. Adding a circle on the left and a square on the right. Adding a circle on the left would be like adding 1, and adding a square on the right would be like adding 2. So the total would be 8 on the left and 9 on the right. 9 is greater than 8, so this hanger is not balanced. E. Adding a triangle on the left and a square on the right. Adding a triangle to the left would be like adding 5, and adding a square on the right would be like adding 2. The total on the left would be 12, and the total on the right would be 9. Since 12 is greater than 9, this hanger is not balanced. Problem number 2. Here is a balanced hanger diagram. Each triangle weighs 2.5 pounds, each circle weighs 3 pounds, and X represents the weight of each square. Select all equations that represent the hanger. These 4 X's in the equation are represented on the left side of the hanger. The 11 in the equation is represented by 2 triangles and 2 circles. 2.5 plus 2.5 is 5, 3 plus 3 is 6, and 5 plus 6 is 11. The right side of the equal sign is represented by the right side of the hanger. On the right side of the equal sign there's only 1 X, but the hanger has 2 X's. So I would say no. Equation A does not match the hanger. At first glance, equation B does not look like a match to the hanger because it only has 2 X's compared to the hanger's 4 X's. However, I suspect that it might be a match. The left side of the hanger has 4x plus 11, and the right side of the hanger has 2x plus 11.5. Now I need to see if the equation for the hanger can match equation B. I'm going to take the 4x and try to turn it into 2x by subtracting 2x from both sides. 2x minus 2x and 4x minus 2x. 2x minus 2x is 0. They cancel each other out. And 4x minus 2x equals 2x. Now the equation reads 2x plus 11 equals 11.5. Since equation B has 2x alone on the left side of the equal sign, I need to get rid of 11 from both sides of this equation. 2x plus 11 minus 11, and 11.5 minus 11. 11 minus 11 cancels each other out, so that's 0. We have the 2x by itself. And 11.5 minus 11 is 0.5. Now the equation reads 2x equals 0.5, and that does match the equation. So B is yes, the equation matches the hanger. Equation C. Here's the 4x plus 5 plus 6. So far so good. On the other side of the equal sign we have the 2x. It matches the 2x on the right side of the hanger, plus 2.5, that's the triangle. And now it says plus 6, but unfortunately on the hanger, they have 9, so there's an extra 3, or an extra circle. So no, this equation does not match the hanger. Equation D. Here's 2x's on the left that match the 2x in the equation. However, we still have 2 more x's. If I cancel them out or remove them from the left side, in order to keep it balanced, I have to remove them from the right side. Here's 2.5 in this triangle, but we still have an extra triangle, so I need to remove that one from the left side, and in order to keep it balanced, I need to remove it from the right side. There are no more terms left on the left side of the equal sign for equation D. That means I'll have to cross out or remove the 2 red circles on the left side of the hanger. So now, in order to keep it balanced, I have to cross out 2 red circles from the right side of the hanger. You'll notice that the only value on the right side of the hanger is a red circle with the value of 3. And the term on the right side of the equal sign for the equation is 3. So yes, this equation matches the hanger. Equation E. Here's the 4x, and 2.5 plus 2.5, that's the 2 triangles on the left, plus 3 plus 3. Those are the 2 red circles on the left. Now we go to the right side of the equal sign. Here's 2x plus 2.5 plus 3 plus 3 plus 3. Yes, this equation matches the hanger. Problem number 3. What is the weight of a square if a triangle weighs 4 grams? Explain your reasoning. Each triangle weighs 4 grams, so we can label each triangle with a 4. If I remove 1 square from each side of the hanger will still be in balance because I've removed the same amount from each side. The right side of the hanger has a value of 12, and the left side of the hanger has a value of 4 plus an unknown number equals 12 because the hanger's balanced. What number plus 4 equals 12? The square is worth 8. Problem number 4. Andre came up with the following puzzle. I am 3 years younger than my brother, and I am 2 years older than my sister. My mom's age is 1 less than 3 times my brother's age. When you add up all our ages, you get 87. What are our ages? A. Try to solve the puzzle. For now, I'm going to start it with this. My age, that represents Andre's age. My age plus 3, that represents Andre's brother's age. My age minus 2, that represents Andre's sister's age. And 3 times my age plus 3 minus 1 equals Andre's mom's age. The total of all these ages is 87. I'm going to substitute my age, or Andre's age, with an x. So x represents Andre's age. X plus 3 represents his brother's age. X minus 2 represents his sister's age. 3 times x plus 3 minus 1 represents Andre's mom's age. I can put all of these terms in order to create an equation that represents Andre's puzzle. This will help me solve for x, Andre's age. Once I know Andre's age, I can substitute the value for x with Andre's age. And that'll help me find out the age of his brother, his sister, and his mother. 3 times x is 3x, and 3 times 3 is 9. This will help me collect like terms. Let's collect all the x's. There's a total of 6 x's. Here's a look at the equation after collecting the x terms. Now let's collect the remaining like terms. 3 minus 2 is 1, 1 plus 9 is 10, and 10 minus 1 is 9. The equation now reads 6x plus 9 equals 87. To get the x by itself, let's subtract 9 from both sides. On the left side of the equal sign, we have 9 minus 9. On the right side of the equal sign, we have 87 minus 9. 9 minus 9 is 0. They cancel each other out. And 87 minus 9 is 78. So the equation reads 6x equals 78. To get the x by itself, we need to divide both sides by 6. 6x divided by 6 and 78 divided by 6. 6x divided by 6 is 1x, or x, and 78 divided by 6 is 13. The value for x is 13, or Andre's age is 13. Now we can substitute the x with a 13. So Andre's age is 13. Andre's brother's age is 13 plus 3, or 16. Andre's sister's age is 13 minus 2, or 11. And Andre's mother's age is 3 times 13 plus 3 minus 1, or 3 times 16, which is 48, minus 1. Andre's mother's age is 47. 13 plus 16 plus 11 plus 47 is 87. B. Jada writes this equation for the sum of the ages. Explain the meaning of the variable and each term of the equation. The x represents Andre's age, x plus 3 represents Andre's brother's age, x minus 2 represents Andre's sister's age, and finally, 3 times x plus 3 minus 1 represents Andre's mother's age. C. Write the equation with fewer terms. This will be the equation after we collected like terms. 6x plus 9 equals 87. D. Solve the puzzle if you haven't already. Andre's 13, Andre's brother's 16, Andre's sister's 11, and Andre's mother is 47. Problem number 5. These two lines are parallel. Write an equation for each. Let's start with the top line that I colored blue. The y-intercept for this line is at the origin, 0 on the y-axis. So the end of the equation will be plus 0. So the equation will be y equals an unknown number times x plus 0, because the 0 is the y-intercept. Now this unknown number is the slope, and the slope is rise over run. Let's figure out what the slope of this line is. The rise is 4, and the run is 5. So the slope is 4/5. Now the equation reads y equals 4/5 x plus 0, which is the same thing as y equals 4/5 x. Let's look at the other line. The y-intercept of the other line is located on the y-axis at negative 3.2. So the equation will read y equals an unknown number times x minus 3.2, because the y-intercept is minus 3.2 or negative 3.2. Let's find the slope of this line. The rise is 4 and the run is 5, so the slope is 4/5. The equation for this line reads y equals 4/5 x minus 3.2. I knew ahead of time that these lines would have the same slope because these lines are parallel. 8th grade Unit 4, Lesson 3, Balanced Moves. Problem number 1. In this hanger, the weight of the triangle is x and the weight of the square is y. A. Write an equation using x and y to represent the hanger. On the left side of the hanger, we have 1x and 3 y's, and on the right side of the hanger, we have 4 x's and 1 y. The equation would read x plus 3y equals 4x plus y. B. If x is 6, what is y? I've labeled all the triangles with a 6 and the squares with a question mark. The first thing I notice is I can get rid of the question mark on the right side and get rid of one of the question marks on the left side. And I did the same thing in the equation. I removed the y from the right side of the equal sign, and now I need to remove a y from the left side of the equal sign. Since we're solving for y, I need to remove the triangle from the left side of the hanger. To keep it balanced, I need to remove one triangle from the right side of the hanger. I also removed a y from both sides of the equal sign. Now the equation reads 2y equals 3x. Look at the right side of the hanger. 6 plus 6 plus 6 equals 18, and it's balanced with the 2 squares on the left side of the hanger. So we have to ask ourselves, what number times 2 equals 18? 9 times 2 equals 18, so I can stop right here. I don't have to go any further. I know that y equals 9. Problem number 2. Match each set of equations with the move that turned the first equation into the second. Equation A started with a 6x and ended up with a 2x. And on the right side of the equation, it started with a 4x minus 3 and ended up with only a minus 3. So it looks like they subtracted 4x from both sides, which is the same thing as adding a negative 4x to both sides. Equations A match the number 4 moves. Equation B, negative 4 times 5x. which would be negative 20x, but then it becomes positive 5x. It became 4 times smaller and was multiplied by a negative. Look at the right side of equation B. It's a little bit easier. It goes from a negative 18 to a positive 4.5. So we know it was multiplied by a negative because a negative times a negative equals a positive, and 4.5 is 4 times smaller than 18, or 1/4 the size of 18. So I would pick move 1. Multiply both sides by negative 1/4. The equations for B match up with the moves for number 1. Let's take a look at the equations for C. It starts out as 8 minus 10x, and then it becomes 4 minus 10x. So it looks to me like they just subtracted 4. And subtracting 4 is the same as adding a negative 4. And look at the right side of the equal sign. 7 minus 4 is 3. So the moves for number 5 match up with the equations for C. Let's look at the right side of equation D. It goes from a 4 to a negative 16. So it becomes 4 times bigger and it becomes a negative. I think both sides must have been multiplied by a negative 4. The moves for 2 match up with the equations for D. And finally, the equations for E. Let's just look at the right side of the equal sign. It goes from a 20x plus 24 down to a 5x plus 6. 5x is 4 times smaller than 20x, and 6 is 4 times smaller than 24. It looks like they've multiplied both sides by 1/4. The steps for 3 match up with the equations for E. Number 3. Andre and Diego were each trying to solve 2x plus 6 equals 3x minus 8. Describe the first step they each made to the equation. A. The result of Andre's first step was negative x plus 6 equals negative 8. Well, it looks to me like Andre subtracted 3x from both sides of the equal sign. 2x minus 3x equals negative 1x, or negative x. So Andre subtracted 3x from each side. That's the same thing as adding a negative 3x to each side. B. The result of Diego's first step was 6 equals x minus 8. On the left side of the original equation, it reads 2x plus 6. After his first step, it only reads 6. He must have subtracted 2x. Let's look at the right side of the equal sign. It went from 3x minus 8 and became x minus 8. He subtracted 2x from both sides of the equal sign, which is the same thing as adding a negative 2x to both sides of the equal sign. Number 4. A. Complete the table with the values for x or y that make this equation true. 3x plus y equals 15. In this table, the x values run horizontally across the top. The equation says 3x. That means that we have to have 3 values for x. The value for x here is 2, so we need 2 plus 2 plus 2, which is 6. 6 plus what number equals 15? 6 plus 9 equals 15, so the value for y is 9, when the value for x is 2. The next column gives us the value for y. 15 minus 3 equals 12, and 12 divided by 3 equals 4. When the value for y is 3, the value for x is 4. Look at the next column. The value for x is 6, and remember it's 3x, so 3 times 6. 3 times 6 is 18. To get from 18 to 15, we need to subtract 3. So the value for y is negative 3 when the value for x is 6. In the next column, the value for x is 0. So 15 minus 0 equals 15. So y is 15 when the value for x is 0. In the next column, the value for x is 3. And 3 times 3 is 9. 15 minus 9 is 6. So when the value for x is 3, the value for y is 6. In the next column, the value for y is 0. 15 minus 0 equals 15. So x must equal 5 because 5 times 3 equals 15. When the value for y is 0, the value for x is 5. The last column's a little bit trickier because the y value is 8. 15 minus 8 equals 7. So what number times 3 equals 7? 2 1/3 times 3 equals 7. And 2 1/3 is also equivalent to 7/3. When the y value is 8, the x value is 7/3, or 2 1/3. B. Create a graph. Plot these points and find the slope of the line that goes through them. I'm going to keep it simple. I'm going to use the far left vertical line as my y-axis and the very bottom horizontal line as my x-axis. And this means that I'm not going to actually plot all the points. I'm not going to be able to go down -3 along the vertical y-axis, and I don't have enough units to go up +15 along the vertical y-axis. I'll start by plotting the point for coordinates 2 and 9. I'll count 2 to the right from the origin along the horizontal x-axis and 9 vertically along the y-axis, and plot my first point. Next, I'll plot the point for coordinates 4 and 3. 4 to the right from the origin along the x-axis, and 3 up from the origin along the y-axis, and plot my second point. It's always a good idea to plot at least 3 points so you know that your line is accurate. Let's plot the point for coordinates 3 and 6. I'll count 3 to the right along the x-axis and 6 vertically along the y-axis, and plot my third point. Next, I'll draw the line running through all 3 points. Next, I need to find the slope. And remember, the slope is the rise over the run. Let's find the rise. The rise is 3. Let's find the run. The run is 1 to the left, so that means -1. 3 divided by -1 is -3, so the slope is -3. Number 5. Select all the situations for which only 0 or positive solutions make sense. A. Measuring temperature in degrees Celsius at an Arctic outpost each day in January. Ooh, that sounds cold. So I'm sure that we would need to have solutions that could also be negative or below 0. Situation A could have solutions of 0, positive, or negative. Let's look at B. The height of a candle as it burns over an hour. Well, it doesn't make sense to think that a candle could burn anything below 0. Once the candle completely melts or burns out, the smallest it could get would be 0. The solutions for situation B could be 0 or positive. C. The elevation above sea level of a hiker descending into a canyon. This one's kind of tricky because they're talking about his location, which is above sea level. However, he is going to descend into the canyon, and it is possible for canyons to be below sea level. The solution for situation C could be 0, positive, or negative, depending on where the hiker is at any time. D. The number of students remaining in school after 6:00 p.m. Well, either there's going to be a few students or there's going to be 0 students. It's impossible to have a negative amount of students remaining at school. So the only answers that make sense for this one are 0 or positive solutions. E. A bank account balance over a year. This one's a little bit tricky too, but sometimes people withdraw or spend too much money, so their balance goes into a negative. So the solution for this one could be negative, 0, or positive. So this one does not make sense to have the solutions only 0 or positive. F. The temperature in degrees Fahrenheit of an oven used on a hot summer day. They give us a few clues. One is that the oven's being used. So if the oven's being used, its temperature will be positive. The other clue is that it's a hot summer day, and a hot summer day's temperature would also be positive. So even if the oven wasn't being used, the temperature of the oven would be a positive temperature. Only zero or positive solutions make sense for situation F. 8th grade Unit 4, Lesson 4, More Balanced Moves. Problem number 1. Mai and Tyler work on the equation 2/5 b plus 1 equals -11 together. Mai's solution is b equals -25 and Tyler's is b equals -28. Here is their work. Do you agree with their solutions? Explain or show your reasoning. Let's start with Mai. It looks like Mai subtracted 1 from the left side of the equal sign, turning 2/5 b plus 1 to just 2/5 b. And on the right side of the equal sign, it looks like Mai added 1, changing the term from -11 to just -10. I don't agree with Mai because she didn't balance the equation. She subtracted 1 on the left side of the equal sign and added 1 on the right side of the equal sign, making the equation out of balance. Let's take a look at what Tyler did. Tyler multiplied 2/5 b by 5 and he multiplied -11 by 5. But Tyler didn't multiply the 1 times 5, making the equation out of balance. I don't agree with Tyler either. Tyler only multiplied some of the terms by 5. Problem number 2. Solve 3 times x minus 4 equals 12x. Use the distributive property to multiply 3 times x, which is 3x, and 3 times a -4, which is -12. Now the equation reads 3x minus 12 equals 12x. To get the x's all on one side, I'm going to subtract 3x from both sides. 3x minus 3x cancels each other out, and 12x minus 3x equals 9x. Now the equation reads -12 equals 9x, but I'd like to know the value for just one x, so I have to get the x by itself. I'll divide 9x by 9 and -12 by 9 to keep them balanced. 9x divided by 9 is 1x, or x, and -12 divided by 9 is -12 over 9, which can be reduced to -4/3. -4/3 equals x, or x equals -4/3. Problem number 3. Describe what is being done in each step while solving the equation. A. This is the original equation. Step B used the distributive property 2 times -3x to get -6x and 2 times +4 to get +8. Step C added 6 to each side. -6x plus 6x cancels each other out, and 5x plus 6x equals 11x. Step D subtracted 2 from each side. 8 minus 2 is 6, and +2 minus 2 cancels each other out. And finally, step E divides both sides by 11. 6 divided by 11 is 6 over 11, and 11x divided by 11 equals 1x, or x. Problem number 4. Andre solved an equation, but when he checked his answer, he saw the solution was incorrect. He knew he made a mistake, but he can't find it. Where is Andre's mistake, and what is the solution to the equation? -2 times 3x is -6x. -2 times -5 is +10, so far so good. 4 times x is 4x, and 4 times 3 is 12. Bring down the 8. -6x plus 10 matches with -6x plus 10. The 4x matches 4x. And 12 plus 8 is 20. So far so good. Add 6x and it cancels each other out, so you just have 10 remaining. Oh, on this side, he subtracted 6x. So on the left side, he added 6x, and on the right side, he subtracted 6x. Andre added 6x to the left side and mistakenly subtracted 6x from the right side. Let's go ahead and solve for x. Add 6x to both sides. Now we have 10 equals 10x plus 20. And to get the x by itself and keep it balanced, I'm going to subtract 20 from both sides. 10x plus 20 minus 20, and 10 minus 20. Now the equation reads negative 10 equals 10x. We want to know what the value for just one x is, so we'll have to divide both sides by 10. 10x divided by 10 and negative 10 divided by 10. Negative 1 equals 1x, or negative 1 equals x. Problem number 5, from 8th grade, Unit 3, Lesson 12. Choose the equation that has solutions 5 and 7 and 8 and 13. Equation A. Let's substitute the x with a 5. 3 times 5 is 15, and substitute the y with a 7. 15 minus 7 equals 8. Since 8 equals 8, this first set of ordered pairs is a solution. Now we have to substitute the x with an 8. 3 times 8 is 24, and substitute the y with a 13. 24 minus 13 equals 11, and 11 does not equal 8. So these two sets of ordered pairs are not both solutions for equation A. Equation B. Let's substitute the y with a 7 and substitute the x with a 5. 7 equals 5 plus 2. And since 5 plus 2 equals 7, 7 equals 7, and this first set of ordered pairs is a solution for equation B. Now we need to substitute the x with an 8 and the y with a 13. And the equation reads 13 equals 10. And since 13 does not equal 10, this second set of ordered pairs is not a solution for equation B. For equation C, we need to substitute the y with a 7 and the x with a 5. So the equation reads 7 minus 5 equals 5. And since 7 minus 5 does not equal 5, this first set of ordered pairs is not a solution for equation C, and we can move on to equation D. For equation D, substitute the y with a 7 and substitute the x with a 5. Now the equation reads 7 equals 2 times 5 minus 3, and 2 times 5 is 10, so it reads 7 equals 10 minus 3. Since 10 minus 3 is 7, and 7 equals 7, this first set of ordered pairs is the solution for equation D. And now the second set of ordered pairs. Substitute the y with a 13 and substitute the x with an 8. The equation reads 13 equals 2 times 8 minus 3. Since 2 times 8 is 16, and 16 minus 3 is 13, and 13 equals 13, both of these ordered pairs are solutions for equation D. Problem number 6, from 8th grade, Unit 3, Lesson 9. A length of ribbon is cut into 2 pieces to use in a craft project. The graph shows the length of the second piece, x, for each length of the first piece, y. A. How long is the ribbon? Explain how you know. The ribbon is 15 feet long. When the length of the first piece is 5 feet, the length of the second piece is 10 feet. B. What is the slope of the line? Remember, the slope is the rise over run. The rise goes up 1 or positive 1, and the run goes to the left 1 or negative 1. So the slope is 1 divided by negative 1 or negative 1. The slope is negative 1. C. Explain what the slope of the line represents and why it fits the story. The slope of this line shows the relationship of the 2 pieces of ribbon. When one piece increases 1 foot in length, the other piece decreases 1 foot in length.
8th grade, Unit 4, Lesson 5, Solving Any Linear Equation. Let's solve linear equations. Learning targets. I can solve an equation where the variable appears on both sides. Number 1. Solve each of these equations. Explain or show your reasoning. Let's use the distributive property to multiply 2 times x, and that's 2x, and to multiply 2 times a positive 5, and that's a positive 10. So on the left side it reads 2x plus 10, and on the right side it reads 3x plus 1. Now, let's collect like terms. Since we have more x's on the right, let's get rid of the x's on the left. 2x minus 2x equals 0, so those x's are canceled out. To keep the equation balanced, we need to subtract 2x from the right side of the equal sign. 3x minus 2x equals 1x, and 1x is the same as x. Now the equation reads 10 equals x plus 1. We still need to get that x all by itself, so we need to take away 1 from the right side. 1 minus 1 cancels each other out, and to keep it balanced we need to take away 1 from the left side. 10 minus 1 is 9. Now the equation reads 9 equals x, which is the same thing as x equals 9. Look at the second equation. There's more y's on the left-hand side, so let's take away the negative 2y on the right-hand side. And we do that by adding 2y. We have to add 2y to both sides to keep it balanced. So on the right, they cancel each other out. On the left, we have 3y plus 2y, and that equals 5y. Now the equation reads 5y minus 4 equals 6. We need to get rid of the minus 4, and we do that by adding 4. But to keep it balanced, we have to add 4 to both sides. So on the left side, they cancel each other out. On the right side, 6 plus 4 equals 10. The equation now reads 5y equals 10. We want to get the y by itself, so we have to divide it by 5. 5y divided by 5 and 10 divided by 5. 5y divided by 5 is 1y, which is the same as y, and 10 divided by 5 is 2, so y equals 2. Look at the third equation. We can use the distributive property to multiply 3 times n and to multiply 3 times a positive 2. On the right-hand side of the equation, we can use the distributive property to multiply 9 times 6 and 9 times a negative n. Now the equation reads 3n plus 6 equals 54 minus 9n. Since the n's on the left-hand side are positive, let's collect our n's on the left-hand side. Negative 9n plus 9n on the right, and then on the left we'll also have to add a positive 9n. So negative 9n plus 9n cancels each other out, and 3n plus 9n equals 12n. Now the equation reads 12n plus 6 equals 54. We still need to get the n by itself on the left, so we have to get rid of the positive 6 by subtracting 6. We need to subtract 6 from both sides. Positive 6 minus 6 cancels each other out, and 54 minus 6 equals 48. Now the equation reads 12n equals 48. We want to know the value for 1n, so we have to divide 12n by 12, and to keep it balanced we have to divide 48 by 12. 12n divided by 12 equals 1n, and 1n is the same as n. The equation reads n equals 48 over 12, and 48 divided by 12 is 4, so n equals 4. Number 2. Claire was solving an equation, but when she checked her answer, she saw her solution was incorrect. She knows she made a mistake, but she can't find it. Where is Claire's mistake, and what is the solution to the equation? Use the distributive property to multiply 12 times 5. Claire wrote down that 12 times 5 was 72, but 12 times 5 is 60. So there's one mistake that Claire made. On the right-hand side of the equal sign, you have a negative times a negative, and Claire wrote the answer as a negative. But a negative times a negative is a positive. So there's the second mistake that Claire made. Let's fix those mistakes and continue solving the equation. On the right-hand side of the equal sign, let's collect the terms with a y. 4y plus 9y equals 13y. Now the equation reads 60 plus 24y equals 13y minus 5. Since there's more y's on the left-hand side of the equal sign, let's get rid of the 13y's on the right side of the equal sign. And to keep it balanced, we have to subtract 13y from the left side of the equal sign. We've canceled out the y's on the right, and 24y minus 13y equals 11y. So now the equation reads 60 plus 11y equals negative 5. We want the y's by themselves, so we'll have to get rid of this 60 from the left, and to keep it balanced, we'll have to get rid of 60 from the right. 60 minus 60 cancels each other out, and negative 5 minus 60 equals negative 65. Now the equation reads 11y equals negative 65. Since we want to solve for the value of y, we need just one y. So we'll have to divide 11y by 11, and to keep it balanced, we have to divide the right side by 11. 11y divided by 11 equals 1y, which is the same as y. And negative 65 divided by 11 doesn't give us a whole number, so we'll just leave it as y equals negative 65 elevenths. Number 3. Solve each equation and check your solution. Let's take a closer look at the first equation. Use the distributive property to multiply 1/9 times 2m and 1/9 times negative 16. On the right-hand side of the equal sign, use the distributive property to multiply 1/3 times 2m and multiply 1/3 times a positive 4. Before I collect like terms, I'll create common denominators. 2/3 m is the same as 6/9 m, and positive 4/3 is the same as positive 12/9. So now the equation has common denominators, and I can collect like terms. Since the value for m is greater on the right side of the equal sign, I'm going to take away 2/9 m from the left side of the equal sign. And to keep it balanced, I'll take away 2/9 m from the right side of the equal sign. We've canceled the m out on the left, and we have a total of 4/9 m on the right. Get the m by itself by subtracting 12/9 from the right side, and to keep it balanced, subtract 12/9 from the left side. We've canceled 12/9 out from the right, and we have negative 28/9 on the left. Now the equation reads negative 28/9 equals 4/9 m. We want to know the value for 1m, so we have to multiply by the reciprocal of 4/9, which means we need to multiply by 9/4. And we have to do that to both sides to keep it balanced. 9 times 4 and 4 times 9 both equal 36. 36 divided by 36 is 1. So now we have 1m. And that's why we multiplied by the reciprocal, to make it 1. And on the left side, we have negative 28/9 times 9/4. And that equals negative 7. Negative 7 equals m, or m equals negative 7. Let's take a closer look at the next equation. Use the distributive property. Make sure you use the distributive property for both terms inside the parentheses. Now the equation reads negative 4r minus 8 equals 8 minus 8r. Since negative 4r is actually greater than negative 8r, I'll add 8r to the right-hand side to cancel out the negative 8r, and to balance it out, I'll add 8r to the left-hand side. This means that I'm collecting the terms with an r on the left-hand side of the equal sign. So anything that doesn't have an r needs to go to the right-hand side of the equal sign. I need to get rid of this negative 8, and I'll do that by adding 8 to both sides to keep it balanced. Now the equation reads 4r equals 16. I still need to get the r by itself. 4r divided by 4, and to keep it balanced, I need to divide 16 by 4. Now the equation reads r equals 4. So the value for r is 4. Let's take a look at the last equation for number 3.
Use the distributive property to multiply by the first term in the parentheses. And don't forget to use the distributive property to multiply by the second term in each set of parentheses. And don't forget to bring down the 4y. Since 24y is larger than 4y plus 9y, let's collect the terms with y on the left side of the equal sign. And we can do this by getting rid of the 4y from the right side of the equal sign. And we have to do that on both sides of the equal sign to keep it balanced. And you have to get rid of 9y from both sides of the equal sign to keep it balanced. I want the term with a y in it to be all by itself on the left side of the equal sign, so I need to get rid of this 60, and I'll do that by subtracting 60 from both sides to keep it balanced. Now the equation reads 11y equals negative 66. I want to know the value for 1y, so I need to divide both sides by 11. Now the equation reads y equals negative 6. Number 4. Here is the graph of a linear equation. Select all true statements about the line and its equation. A. One solution of the equation is the ordered pair 3 and 2. I plotted the point for ordered pair 3 and 2, and the point lands on the line. Statement A is a true statement. B. One solution of the equation is ordered pair -1 and 1. And since this point also lands on the line, statement B is a true statement. C. One solution of the equation is ordered pair 1 and 3/2. This point also lands on the line, so statement C is also a true statement. D. There are two solutions. The length of this line is infinite. Therefore, there's an infinite number of points that could fit on this line. So statement D is not true because there are an infinite amount of solutions. E. There are infinitely many solutions. Well, we've already discovered that that's true. F. The equation of the line is y equals 1/4 x plus 5/4. Let's use the ordered pairs 3 and 2 since they are a solution to the equation. Let's substitute the y with the 2 and the x with the 3. Now the equation reads 2 equals 1/4 times 3/1 plus 5/4. 1/4 times 3 equals 3/4. 3/4 plus 5/4 equals 8/4, and 8/4 is equivalent to 2. So this is a solution. Since 2 does equal 2, the statement for F is true. G. The equation of the line is y equals 5/4 x plus 1/4. Again, let's use the ordered pairs 3 and 2, so we'll substitute the y with the 2 and the x with the 3. 5/4 times 3 equals 15/4, and 15/4 plus 1/4 is 16/4, and 16/4 is 16 divided by 4, which is 4, and 2 does not equal 4. Statement G is not true. Number 5. A participant in a 21-mile walkathon walks a steady rate of 3 miles per hour. He thinks the relationship between the number of miles left to walk and the number of hours I already walked can be represented by a line with a slope of -3. Do you agree with his claim? Explain your reasoning. This represents a graph with the hours walked along the x-axis or horizontal axis and the miles remaining along the vertical axis or the y-axis. And notice that this line has a negative slope. The number of miles remaining decreases as the hours walked increases. The rise is a -3 and the run is a +1. That means the slope is -3. Yes, I agree. Open up resources. Illustrative Mathematics, 8th grade, Unit 4, Lesson 6. Strategic Solving. Number 1. Solve each equation and explain your reasoning. A. Collect like terms. Add 13 to both sides. Add 5 to both sides. Collect the like terms. Take away 2b from both sides. Add 5b to both sides. (29 = 11b). Divide both sides by 11. 29/11 equals b, or b equals 29/11. B. Combine the like terms. 3 times 5 plus 3 times 6x minus 12x equals 6x. Add 3x to both sides. Subtract 15 from both sides. Divide both sides by 9. 0 equals 1x, or 0 equals x, or x equals 0. C. Collect like terms. 2 times 6 is 12 minus 2 times c. 12 minus 2c. Take away 12 from both sides. -3 minus 12 is -15. Subtract 2c from both sides. -4c plus 7c. That's the same as 7c minus 4c. Divide each side by 3. 1c, or c, equals -5. -5 equals c, or c equals -5. Number 2. Solve each equation and check your solution. A. -3w minus 4 equals w plus 3. Collect like terms. Add 3w to both sides. Subtract 3 from each side. Divide each side by 4. -7/4 is the same as -7/4. So -7/4 equals w, or w equals -7/4. B. Collect like terms. 3 times 3 minus 3 times 3x. 2 times x plus 2 times 3. Now the equation reads 9 minus 9x equals 2x plus 6 minus 30. Subtract 2x from both sides. 6 minus 30 equals -24. Subtract 9 from both sides. -11x equals -33. So divide both sides by -11. And you'll have a positive 1x, or x. X equals 3. C. I'll perform the operations and collect like terms. 1/3 times z, that's 1/3 z, plus 1/3 of 4, that's 4/3. Bring down the -6, and 2/3 of 5 is 10/3, minus 2/3 of z. Add 2/3 z to both sides. 1/3 z plus 2/3 z equals 3/3 z, or 1z. Subtract 4/3 from each side. 10/3 minus 4/3 equals 6/3, and 6/3 is 2. Add 6 to each side. Z equals 8. Number 3. Elena said the equation 9x plus 15 equals 3x plus 15 has no solution because 9x is greater than 3x. Do you agree with Elena? Explain your reasoning. I disagree with Elena. When the value of x is 0, 9x and 3x would have the same value. That's because 9 times 0 is 0, and 3 times 0 is also 0. Number 4. The table gives some sample data for two quantities, x and y, that are in a proportional relationship. 14 divided by 14 equals 1. And 21 divided by 14 equals 21/14. 21 divided by 7 is 3, and 14 divided by 7 is 2. When the value of x is 1, the value of y will be 3/2, or 3/2. When the value of x is 64, to find the value of y, we would multiply 64 and 3/2. 64 times 3/2 equals 96. So when the x value is 64, the y value is 96. When the y value is 39, we can find the missing x value by dividing 39 by 3/2. And 39 divided by 3/2 is going to be equal to 39 times the reciprocal of 3/2, or 39 times 2/3. And 39 times 2/3 is 26. So when the y value is 39, the x value is 26. An equation that represents the proportional relationship between x and y is y equals 3/2 x. Here's a graph that represents this relationship, complete with points on the graph. When the value for x is 20, the value for y would be 30. When the value for x is 40, the value for y would be 60. And when the value for x is 60, the value for y would be 90. Search hashtag 846math to find this lesson fast. 8th grade, Unit 4, Lesson 6, Math. This is a fast way for you to go to any of the 6th, 7th, and 8th grade math lessons that I've made for Illustrative Math. Thanks for watching. 8th grade, Unit 4, Lesson 7, All, Some, or No Solutions. Problem number 1. For each equation, decide if it is always true or never true. A. X minus 13 equals x plus 1. If I add 13 to both sides, the equation reads x equals x plus 14, and this is never true. B. X plus 1/2 equals x minus 1/2. That is never true. C. 2 times x plus 3 equals 5x plus 6 minus 3x. Use the distributive property to multiply 2 times x and you get 2x, and 2 times a positive 3 you get a positive 6. And collect like terms, 5x minus 3x, that's 2x. Now the equation reads 2x plus 6 equals 2x plus 6, and that's always true. D. X minus 3 equals 2x minus 3 minus x. Collect the x's on the right-hand side of the equal sign. X is the same thing as 1x, so we have 2x minus 1x, and that's 1x, or x. Bring down the minus 3, and the equation now reads x minus 3 equals x minus 3, and that's always true. E. 3 times x minus 5 equals 2 times x minus 5 plus x. Use the distributive property to multiply 3 times x, and that's 3x. 3 times negative 5, that's a negative 15. Use the distributive property to multiply 2 times x, that's 2x. And 2 times a negative 5, that's negative 10. And bring down the plus x. Collect like terms. Collect 2x and 1x. That becomes 3x. 3x minus 15 does not equal 3x minus 10, so that is never true. Problem number 2. Mai says that the equation 2x plus 2 equals x plus 1 has no solution because the left-hand side is double the right-hand side. Do you agree with Mai? Explain your reasoning. 2x plus 2 equals x plus 1. Let's collect the x's on the left-hand side. So we'll subtract 1x from the right and subtract 1x from the left to keep it balanced. Now the equation reads 1x, or x, plus 2 equals positive 1. Well, we need to get rid of the 2 on the left-hand side to get the x alone. So we have to subtract 2 from the left side and subtract 2 from the right side to keep it balanced. Since x equals negative 1 is a solution, then I can disagree with my. Problem number 3. A. Write the other side of this equation so that it's true for all values of x. Use the distributive property to multiply 1/2 times 6x, and half of 6x is 3x, and 1/2 times negative 10. 1/2 of negative 10 is negative 5. Bring down the negative x, and collect like terms. We have negative 1x and 3x. So 3x minus 1x is 2x. So now the equation reads 2x minus 5. The other side of the equation could read 2x minus 5. B. Write the other side of the equation so it's true for no values of x. All I have to do is make a little change. I can change the 2x minus 5 to 2x plus 5, and it would be true for no values of x. Problem number 4. Here is an equation that is true for all values of x. Elena saw this equation and says she can tell 20 times x plus 2 plus 31 equals 4 times 5x plus 10 plus 31 is also true for any value of x. How can she tell? Explain your reasoning. I'm going to use the distributive property to multiply 20 times x, that's 20x, and 20 times a positive 2, that's positive 40. I'll bring down the positive 31, and on the other side of the equal sign, I'll use the distributive property to multiply 4 times 5x, that's 20x, and 4 times a positive 10, that's positive 40. And I'll bring down positive 31. Now it's pretty easy to tell because both sides of the equation have the same terms. Problem number 5, from 8th grade, Unit 4, Lesson 4. Elena and Lynn are trying to solve this equation. Describe the change they each make to each side of the equation. A. Elena's first step is to write 3 equals 7/2 x minus 1/2 x plus 5. There's a 1/2 x missing from the left-hand side of the equal sign, and there's a negative 1/2 x added to the right side of the equal sign. So Elena's first step was subtracting 1/2 x from each side. That's the same thing as adding a negative 1/2 x to each side. B. Lynn's first step is to write x plus 6 equals 7x plus 10. The half x doubled and became 1 whole x. The 3 doubled and became a 6. 7/2 x doubled and became 7x. And 5 doubled and became 10. Lynn's first step multiplied every term by 2. Problem number 6 from 8th grade, Unit 4, Lesson 6. Solve each equation and check your solution. Use the distributive property to multiply 4 times 2, that's 8, and 4 times a negative 3x, that's a negative 12x. Bring down the negative 8x and combine like terms. We have negative 12x and negative 8x. That combines to negative 20x. For now, I'll put all the x's on the right-hand side of the equal sign by subtracting 3x from both sides to keep it balanced. Negative 3x is canceled out on the left side, and negative 20x plus a negative 3x is negative 23x on the right side. To get the x by itself, I have to subtract 8 from both sides of the equal sign. On the right-hand side, the 8 is canceled out. Negative 6 minus 8 equals negative 14 on the left-hand side. Since both sides of the equal sign are negatives, I'm going to multiply both sides by a negative 1, making both of these terms positive. I want just one x, so I need to divide 23x by 23 And to keep it balanced, I need to divide 14 by 23. Now the equation reads 14/23 equals x. So x equals 14/23. Now we have to check our solution by substituting all the x's with 14/23. I'm going to use the distributive property to multiply 4 times 2, that's 8, and 4 times -3 times 14/23. I'm going to combine these like terms. I have -12 times 14/23 and -8 times 14/23. That combines to a total of -20 times 14/23. I'm going to get rid of the positive 8 on the right-hand side of the equal sign by subtracting 8 from both sides of the equal sign to keep it balanced. And I'm going to subtract 3 times 14/23 from both sides of the equal sign. Let's find out what -23 times 14/23 equals. The 23 cancels each other out. Now we have -14 over 1. The equation reads -14 equals -14. So we've just checked our solution. Use the distributive property to multiply 3/2 times z, that's 3/2 z, and 3/2 times +6, that's +9. Subtract 1/2 z from both sides of the equal sign to balance it out, and you have 6 equals 1z plus 9. Subtract 9 from both sides, and you have -3 equals z. Now we can check our solution. Let's substitute all the z's with the -3. 1/2 of -3 is -1.5. 6 minus 1.5 is 4.5. 6 minus 3 is 3. 3/2 times 3 equals 9/2. 9 divided by 2 equals 4.5. We just checked our solution. 4.5 equals 4.5. Since we have more w's on the right-hand side of the equal sign, I'm going to get rid of 8 on both sides to get the w by itself. To get rid of the minus 7w, I have to add 7w on both sides. Now the equation reads 1 equals 15w. I want to know what the value is for 1w, so I have to divide both sides by 15. Now the equation reads 1/15 equals w, or w equals 1/15. Now that we know w equals 1/15, we can substitute 1/15 for all the w's. Subtract 8 from both sides. Add 7 times 1/15 to both sides. And now the equation reads 1 equals 1. We just checked our solution. Problem number 7 from 8th grade, Unit 3, Lesson 12. The point with coordinates -3 and 6 is on a line with a slope of 4. A. Find 2 more points on the line. Slope of 4 means y minus y over x minus x equals 4 over 1. Let's substitute the first y with the 6. 6 minus y equals 4. 6 minus what number equals 4? 6 minus 2 equals 4. In the new ordered pair, y equals 2. Now substitute the first x with the -3. -3 minus x equals 1. -3 minus what number equals 1? -3 minus a -4 equals 1, because minus a negative is like a positive. So that would be -3 plus 4 equals 1, or 4 minus 3 equals 1. -4 would be the value for x in our new ordered pair. The instructions say find 2 more points on the line. We found 1 point, now we have to find another. Let's plug in the values for x and y from our new ordered pair. 2 minus what number equals 4? Well, 2 plus 2 equals 4, so let's go with 2 minus a -2. In this new ordered pair, y equals -2. Let's find the value for x when y is -2. -4 minus what number equals 1? -4 minus a -5 equals 1, because minus a negative makes a positive. So this would be like negative 4 plus 5 equals 1, or 5 minus 4 equals 1. The values for this ordered pair are negative 5 and negative 2. B. Write an equation for the line. To write an equation for the line, I know that y equals the slope times x plus the y-intercept. So I need to know what the slope is, and I need to know what the y-intercept is. Let's start with the y-intercept. When the value for x is 0, the y value is the y-intercept. For this line, I think the ordered pair for the y-intercept is 0 and 18. Let's double check. Y minus y, 18 minus 6 equals 12. X minus x, 0 minus a negative 3 equals 3. 12 divided by 3 equals 4. The slope of this ordered pair is 4, so it checks out. The y-intercept is 18. Since the slope is 4, we can multiply 4 times x, and the y-intercept is 18. We have everything we need to know to write the equation because we know that y equals the slope times x plus the y-intercept. Now we know the equation. Y equals 4x plus 18. 8th grade Open Up Resources, Illustrative Mathematics, Unit 4, Lesson 8. How many solutions? Glossary term. Constant term. In an expression like 3y plus 5, the number 5 is the constant term because it doesn't change when the variable y changes. Examples: 2x plus 3. The 3 is the constant term. 8 minus 4y. The 8 is the constant term. Number 1. Lynn was looking at the equation. She said, I can tell right away that there are no solutions because on the left side you will have 2x plus 12x and a bunch of constants. But you have just 14x on the right side. Do you agree with Lynn? Explain your reasoning. I agree with Lynn. There are no solutions because 14x plus 9,848 minus 32 does not equal 14x. Number 2. Han was looking at the equation. He said, I can tell right away there are no solutions because on the left side you will have 6x plus 10x and a bunch of constants, but you have just 16x on the right side. Do you agree with Han? Explain your reasoning. If you perform all the operations, you'll figure out that Han is incorrect because 16x plus 0 equals 16x, and that's true for all values of x. Han is incorrect. Number 3. Decide whether each equation is true for all, one, or no values of x. A. 6x minus 4 equals negative 4 plus 6x. Since 6x minus 4 is the same as negative 4 plus 6x, this equation is true for all values of x. B. 4x minus 6 equals 4x plus 3. Since 4x minus 6 is never equal to 4x plus 3, this is true for no values of x. C. Negative 2x plus 4 equals negative 3x plus 4. When x is equal to 0, this is true. So this equation is true for one value of x. Number 4. Solve each of these equations. Explain or show your reasoning. 3 times x is 3x, and 3 times negative 5 is negative 15. Bring down the equal sign and the 6 on the right-hand side. Add 15 to both sides, and you have 3x equals 21. To get the x alone, you divide by 3. 3x divided by 3 equals 1x, or x. And since we divided the left side by 3, we divide the right side by 3. 21 divided by 3 is 7. X equals 7. B. 2 times x minus 2 times 2/3 equals 0. 2 times x is 2x. 2 times negative 2/3 is negative 4/3. Bring down the equal sign and the 0 on the right. Add 4/3 to both sides of the equal sign, and you'll have 2x equals 4/3. To get the x by itself, we'll have to divide by 2. 2x divided by 2 equals 1x, or x. Since we divided the left side by 2, we have to divide the right side by 2. And 4/3 divided by 2 equals 4/6, which is equivalent to 2/3. X equals 2/3. C. 4x minus 5 equals 2 minus x. I'm going to get the x's on one side. So on the right hand side, I'm going to add 1x to get rid of the negative x. And on the left hand side, I also have to add 1x. And 4x plus x equals 5x. Now the equation reads 5x minus 5 equals 2. I need to get rid of the negative 5, so I'm going to add 5 to the left side, and then I'm going to add 5 to the right side. Now the equation reads 5x equals 7. I'm almost done. I need to divide the 5x by 5 to make it 1x, or x, and then I have to divide the right-hand side by 5. 7 divided by 5 equals 7/5, or 1 2/5. X equals 7/5, or x equals 1 2/5. Number 5. The points -2 and 0, and 0 and -6 are each on the graph of a linear equation. Is 2 and 6 also on the graph of this linear equation? Explain your reasoning. All three of these points together would not make a straight line. Here's a look at the line that the first two sets of points create. As you can see, the points 2 and 6 would not land on that line. Points 2 and 6 are not on the graph of the linear equation that points -2 and 0 and -6 are on. Number 6. In the picture, triangle A prime, B prime, C prime is an image of triangle ABC after a rotation. The center of rotation is E. A. What is the length of side AB? Explain how you know. The length of side AB is the same as the length of side A prime B prime, and since A prime B prime's length is 9, or 9 units, then the length for side AB will also be 9 units. B. What is the measure of angle D prime? Explain how you know. Well, since the angle for D prime will be the same as the angle for D, and the angle for D is 45 degrees, the angle for D prime will also be 45 degrees. Eighth grade, Unit 4, Lesson 9. When are they the same? Problem 1. Cell phone plan A costs $70 per month and comes with a free $500 phone. Cell phone plan B costs $50 per month but does not come with a phone. If you buy the $500 phone and choose plan B, how many months is it until your cost is the same as plan A's? Okay, so you bought the $500 phone and chose plan B. So that's $500 plus $50 per month. For plan A, the phone is free, so it's just $70 per month. Plan A, the first month is $70, and plan B, the first month is $550. For plan A, after 2 months, you would pay $140, and for plan B, after 2 months, you would have paid $600. The question is, how many months is it until plan B costs the same as plan A? After 25 months, plan B costs $1,750 and plan A costs $1,750. We could write this out as an equation. 70x equals 500 plus 50x. And subtract 50x from both sides. Now the equation reads 20x equals 500. Divide both sides by 20. And the equation now reads x equals 25. At the 25th month, the cost is the same for Plan B and Plan A. Problem number 2. Priya and Han are biking in the same direction on the same path. A. Han is riding at a constant speed of 16 miles per hour. Write an expression that shows how many miles Han has gone after t hours. The expression would be 16t miles. B. Priya started riding a half hour before Han. If Han has been riding for t hours, how long has Priya been riding? Since Priya started riding a half hour before Han, Priya has been riding t plus 1/2 hours. C. Priya is riding at a constant speed of 12 miles per hour. Write an expression that shows how many miles Priya has gone after Han has been riding for t hours. Since Priya is riding at a constant speed of 12 miles per hour, the expression would read 12 times t plus 1/2. D. Use your expressions to find when Han and Priya meet. Han's expression is 16 t miles. Priya's expression is t plus 1/2 hours. And the expression that represents Priya riding at a constant speed of 12 miles per hour is 12 times t plus 1/2. We'll use this expression and Han's expression to help us find when Han and Priya will meet. 16t miles equals 12 times t plus 1/2. That's the same as 16t equals 12 times t plus 1/2. 12 times t equals 12t. 12 times 1/2 equals 6. Now the equation reads 16t equals 12t plus 6. Subtract 12t from both sides. And now the equation reads 4t equals 6. Divide both sides by 4. And now the equation reads t equals 6/4, which is equivalent to 3/2 or 1.5. Han and Priya will meet in 1.5 hours. Problem number 3. Which story matches the equation -6 plus 3x equals 2 plus 4x? So for story A, I see some values that make sense. The -6, the 2, the 3, the 4. In story B, this is what doesn't make sense. They're playing a card game where every time they collect a pair of matching cards, they earn X amount of points. Karen has -6 points. I don't understand how they can earn negative points if you're earning points for every time you have a pair of matching cards. So I'm going to go with story A as the story that matches the equation. Problem number 4. For what value of x do the expressions have the same value? Subtract 2/3 x from each side. Add 6 to both sides. Multiply both sides by the reciprocal of 2/3, which is 3/2. When the value of x is 12, the expressions have the same value. Problem number 5. From 8th grade, Unit 4, Lesson 8. Decide whether each equation is true for all, 1, or no values of x. A. 2x plus 8 equals -3.5x plus 19. Add 3.5x to both sides. Subtract 8 from each side. Now the equation reads 5.5x equals 11. Divide both sides by 5.5. X equals 2. And this is true for one value of x. B. 9 times x is 9x. 9 times a -2 is -18. Subtract 7x from both sides. Add 18 to both sides. Divide both sides by 2. And x equals 11.5. This is true for one value of x. C. 3 times 3x is 9x. 3 times 2 is 6. Bring down the negative 2x. 9x minus 2x is 7x. Now the equation reads 7x plus 6 equals 7x plus 6. This is true for all values of x.
Problem number 6 from 8th grade, Unit 4, Lesson 6. Solve each equation. Explain your reasoning. A. Negative 2 times 5 is negative 10. Negative 2 times negative 3d equals positive 6d. Subtract 3d from both sides. Now the equation reads 16 equals negative 10 plus 3d. Add 10 to both sides. Now the equation reads 26 equals 3d. Divide both sides by 3. And the value for d equals 26 thirds, or 8 2/3. B. Negative 3 times 4 equals negative 12. Negative 3 times negative k equals positive 3k. Now the equation reads 2k minus 12 plus 3k equals 3k plus 4. Combine like terms. 2k plus 3k equals 5k. Now the equation reads 5k minus 12 equals 3k plus 4. Subtract 3k from both sides. Add 12 to both sides. Now the equation reads 2k equals 16. Divide both sides by 2 and k equals 8. C. I could rewrite this as 3y over 9 minus 6 over 9 equals 4 over negative 3 minus 2y over negative 3. Minus a negative, or the opposite of a negative, is a positive. So you can rewrite negative 2y over negative 3 as positive 2y over 3. Since we're adding and subtracting fractions, let's get common denominators. Let's make the negative 3 a negative 9 by multiplying it by 3, and multiply the 4 by 3 to make it 12, and multiply the 3 by 3 to make it 9, and the 2y by 3 to make it 6y. Subtract 3y over 9 from both sides. Add 12 ninths to both sides. Combine like terms. 12 ninths minus 6 ninths equals 6 ninths. Multiply both sides by the reciprocal of 3 ninths, which is 9 thirds. Right now you can multiply straight across, or you can cross cancel. 9 goes into 9 once, 3 goes into 3 once, and 3 goes into 6 twice. Now we can multiply straight across, and the value for y is 2. Problem number 7. Describe a rigid transformation that takes polygon A to polygon B. Here's what we can do. Here's another look at it. Rotate polygon A 180 degrees around center point 0, 0. 8th grade, Unit 4, Lesson 10, On or Off the Line. Problem number 1. A. Match the lines M and N to the statements they represent. A set of points where the coordinates of each point have a sum of 2. Let's look at line N and try point A. The coordinates for point A are negative 2 and 4. That's like negative 2 plus 4, or 4 plus a negative 2, which is the same as 4 minus 2. And 4 minus 2 equals 2. So we can say that the sum is 2. Next, let's look at another point on line N, point C. The coordinates for point C are 12 and negative 10. That's like 12 minus 10, or 12 plus a negative 10. So the sum is 2. The coordinates of the points on line N have the sum of 2. A set of points where the y-coordinate of each point is 10 less than its x-coordinate. Let's look at point E on line M. The coordinates are 13 and 3. The x-coordinate minus 10 equals 3, so the y-coordinate is 10 less than the x-coordinate. Next, let's look at point D on line M. The coordinates for point D are 2 and -8, and the difference between 2 and -8 is 10, so the y-coordinate is 10 less than the x-coordinate.
Line M contains sets of points where the y-coordinate of each point is 10 less than its x-coordinate. B. Match the labeled points on the graph to statements about their coordinates. Point A, the coordinates are -2 and 4, and the sum of -2 and 4 is 2. Now let's look at the coordinates for point B. The coordinates for point B are 6 and -4, and the sum of 6 and -4 is 2. There's another point on this line, point C, and its coordinates are 12 and -10, and the sum of 12 and -10 is also 2. For the second one, we need to find two numbers where the y-coordinate is 10 less than the x-coordinate. Look at point B. The coordinates for point B are 6 and -4. -4, or the y-coordinate, is 10 less than 6, the x-coordinate. Now look at point D. Point D's coordinates are 2 and -8. -8, the y-coordinate, is 10 less than 2, the x-coordinate. There's another point on line M that we can look at, and that's point E. Point E's coordinates are 13 and 3. 3, the y-coordinate, is 10 less than 13, the x-coordinate. For the third and last one, we need to find two numbers with a sum of 2 and where the y-coordinate is 10 less than the x-coordinate. They're asking us to find two numbers that we've already found. If you notice, point B was in the first one and point B was in the second one. So let's look at point B. Its coordinates are 6 and -4. The sum of 6 and -4 is just like 6 minus 4. So the sum of 6 and -4 is 2. And the difference of the y-coordinate is 10 less than the x-coordinate because -4 is 10 less than 6. Problem number 2 from 8th grade, Unit 4, Lesson 7. Here's an equation. 4x minus 4 equals 4x plus what number? What could you write in the blank so the equation would be true for A, no values of x? Let's come back to this one later. B, all values of x. 4x minus 4 equals 4x plus a -4 because 4x plus a -4 is the same as 4x minus 4. To make it true for all values of x, we would put a -4 in the blank, and that would mean that x can be any number when you fill in the blank with a -4. C, one value of x. To make this equation true for just one value of x, we could put plus 4x in that blank. Here's why. Subtract 4x from both sides, and they cancel each other out, and you're left with -4 equals 4x. Make just one x by dividing both sides by 4. That leaves us with 1x and -1. So x equals -1. That's one value of x. X equals -1 when you fill in the blank with a 4x. Let's go back to A. What could you write in the blank so the equation would be true for no values of x? Fill in the blank with any number other than -4. For example, you can fill in the blank with a 5 or a 17 or a 25, and the equation would be true for no values of x. Problem number 3. Mai earns $7 per hour mowing her neighbor's lawns. She also earned $14 for hauling away bags of recyclables for some neighbors. Priya babysits her neighbor's children. The table shows the amount of money M she earns in H hours. Priya and Mai have agreed to go to the movies the weekend after they have earned the same amount of money for the same number of work hours. A. How many hours do they have to work before they go to the movies? This chart on the right represents Priya's situation, and I can tell that Priya earns $8.40 each hour. Now let's look at the beginning of the problem when they talk about Mai's situation. Not only does Mai earn $7 per hour for mowing her neighbor's lawns, but she also earned $14 for hauling away recyclables. I'm going to use Mai's information on the left and Priya's information on the right to help me find out when they're equal. I can write this equation: 7h plus 14 equals 8.40h. Mai's information is on the left, $7 per hour plus $14, and Priya's information is on the right, $8.40 an hour. This equation should show me when they have worked an equal amount of time. I can subtract 7h from both sides. That would leave me with 14 equals 1.40h. I want to know what the value is for 1h, so I'm going to divide both sides by 1.40. That leaves me with 10 equals h. They would work 10 hours before they would have earned the same amount of money for the same number of work hours. B. How much would they have earned? 10 hours times $8.40 is $84. After 10 hours, they would have earned $84. Look at the top of the page. Mai earns $7 an hour, so $7 times 10 hours equals $70. Add that to the $14 that she was paid for hauling away recyclables, and she earned a total of $84 after 10 hours. C. Explain where the solution can be seen in tables of values, graphs, and equations that represent Priya's and Mai's hourly earnings. They've made a table for Priya, but we can make a table for Mai. Mai earns in 1 hour $7 plus the $14 for the recyclables. That means that in 2 hours she earns $14 plus that same $14 for the recyclables. In 4 hours, Mai would earn $28 plus that $14 for the recyclables. This can be represented in a graph. The x-axis or the horizontal axis represents the hours, and the vertical axis or the y-axis represents the amount of money. I've highlighted 10 hours and I've identified $84, so we can put a point at 10 hours and $84. This point represents both Priya and Mai. That means when we graph a line for Priya and we graph a line for Mai, this point will be where those two lines intersect. Mai's line will start at $14 along the y-axis, and Mai earned an additional $7 for her first hour of work, so we can put a point at 1 hour and $21. Now you can draw a line through those points, 1 and 21, and 10 and 84. The purple line belongs to Mai. Priya's line is going to start at the origin, which is 0 along the x-axis and 0 up on the y-axis. You can run that line from the origin straight through the point at 10 hours and $84. The black line represents Priya. And finally, we can go back to the equation that we created that represents this situation. 8.4h equals 7h plus 14. 8.4h is the same as $8.40 an hour, and that represents Priya, and 7h plus 14 represents Mai, $7 an hour plus $14 for hauling away the recyclables. Here's a look at all three: the chart, the graph, and the equation. Problem number 4, from 8th grade, Unit 4, Lesson 6. For each equation, explain what you could do first to each side of the equation so that there would be no fractions. You do not have to solve the equations unless you want more practice. Equation A. 24 is the least common multiple of 8 and 3, so you could multiply each side by 24. That would get rid of the fractions, and the equation would look like this.
3 times 3x minus 4 equals 8 times x plus 2. B. 12 is the least common multiple of 4 and 6. Multiply each side by 12. That would get rid of the fractions. Now the equation would read 9 times 2 minus r equals 2 times 3 plus r. C. 8 is the least common multiple of 8 and 4, so multiply each side by 8. That would get rid of the fractions, and your equation would be 4p plus 3 equals 2 times p plus 2. D. 30 is the least common multiple of 6 and 15. Multiply each side by 30, and that would get rid of the fractions. Now your equation would read 4 times a minus 7 equals 5 times a plus 4. 8th grade, Unit 4, Lesson 11, on both of the lines. Problem number 1. Diego has $11 and begins saving $5 each week towards buying a new phone. At the same time that Diego begins saving, Lynn has $60 and begins spending $2 per week on supplies for her art class. Is there a week when they have the same amount of money? How much do they have at the same time? We can start by writing an equation for Diego. His equation would be t equals 11 plus 5w. I think of this as time equals the $11 that he started with plus $5 each week. Next, we can write Lynn's equation. Lynn's equation would be t equals 60 plus negative 2w. I like to think of this as time equals the $60 that she started with plus the $2 that she spends each week. To solve when they would have the same amount, set both equations to be equal. So we can write Diego's equation, 11 plus 5w, equals Lynn's equation, 60 minus 2w. Solve for w. Add 2w to both sides of the equal sign. Subtract 11 from both sides of the equal sign. And then finally, divide both sides by 7. W equals 7. That means that at week 7, they would have the same amount. To find out how much they both will have at week 7, substitute the W with a 7. Now Diego's equation reads 11 plus 35 equals 46. And Lynn's equation reads 60 minus 14 equals 46. They both will have $46 at week 7. Problem number 2. Use a graph to find x and y values that make both these equations true. The line for this first equation should intersect the y-axis at 3 and have a slope of negative 2/3. The second equation should have a line that intersects the y-axis at negative 5 and have a slope of 2. The point where these two lines meet or intersect will have the ordered pairs x and y that make both these equations true. The ordered pairs 3 and 1 make both these equations true. Problem number 3. The point where the graphs of two equations intersect has y-coordinate 2. One equation is y equals negative 3x plus 5. Find the other equation if the graph has a slope of 1. Let's start by putting a point at the location where the two equations intersect. That would be at the y-coordinate 2. To make the second line, or to make the second graph, we can start at that point and move up 1 and to the right 1, since it has a slope of 1. We could also start at that point and move to the left 1 and down 1. Draw a straight line directly through these points and it represents the graph of the second equation. Since the second equation has a slope of 1 and a y-intercept of 1, its equation would be y equals 1x plus 1. Problem number 4 from 8th grade, Unit 4, Lesson 10. A farm has chickens and cows. All the cows have 4 legs, and all the chickens have 2 legs. Altogether,
There are 82 cow and chicken legs on the farm. Complete the table to show some possible combinations of chickens and cows to get 82 total legs. If there are 35 chickens times 2 legs equals 70. So 82 total legs minus 70 equals 12. What number times 4 equals 12? 3 times 4. So if there were 35 chickens, there'd be 3 cows. If there were only 7 chickens, 7 times 2 equals 14. And 82 minus 14 equals 68. 68 legs divided by 4 legs equals 17. So if there were 7 chickens, there would be 17 cows. If there were 10 cows times 4 legs equals 40 legs. And 82 legs minus 40 legs equals 42 legs. So 42 legs divided by 2 equals 21. So if there were 10 cows, there would be 21 chickens. If there were 19 chickens, there would be 38 legs. And 82 legs minus 38 legs equals 44 legs. So 44 legs divided by 4 equals 11. So if there were 19 chickens, there would be 11 cows. And finally, if there were 5 cows, 5 times 4 equals 20, so that would account for 20 legs. 82 minus 20 is 62. 62 divided by 2 is 31. So if there were 5 cows, there would be 31 chickens. Problem number 5. Here is a graph that shows possible combinations of chickens and cows that add up to 30 animals. If the farm has 30 chickens and cows, and there are 82 chicken and cow legs altogether, then how many chickens and how many cows could the farm have? Chickens plus cows equals 30. So we can use C to represent chickens and W to represent cows. There are 82 chicken and cow legs altogether. Since chickens have 2 legs, we can multiply 2 times C, and cows have 4 legs. We can multiply W times 4. So we can write the equation 2C plus 4W equals 82. 82 stands for the total number of legs. We can solve for C in the first equation, then substitute the value of C in the second equation. To get the C by itself, we have to subtract W from both sides. Now the equation reads C equals 30 minus W. Now we know the value for C is 30 minus W. So we can substitute the C in the second equation with 30 minus W. So now the equation reads 2 times 30 minus W plus 4W equals 82, which can be written as 60 minus 2W plus 4W equals 82. We can collect like terms, and 4W minus 2W equals 2W. Let's get the term with the W in it by itself, and we can do that by subtracting 60 from both sides. 60 minus 60 cancels each other out, and 82 minus 60 equals 22. Now the equation reads 2W equals 22. Let's make that just one W by dividing both sides by 2. W equals 11. Since W represented cows, we know that we have 11 cows. If there were 30 animals altogether, 30 minus 11 equals 19, so we must have had 11 cows and 19 chickens. 8th grade, Unit 4, Lesson 12, Systems of Equations. If you haven't subscribed, now's a good time to subscribe, and while you're down there, please hit that like button. I appreciate it. Thanks. Problem number 1. Here is the graph for one equation in a system of equations. A. Write a second equation for the system so it has infinitely many solutions. In order for a line to have infinitely many solutions with another line or equations, both have to have the same slope and the same y-intercept. For this line, the y-intercept is 4, and the slope is negative 3/4. So we could write the equation y equals negative 3/4 x plus 4. B. Write a second equation whose graph goes through ordered pair 0, 1, so the system has no solutions. In order to have both equations share no solutions, they both have the same slope and different y-intercept. I drew in this red line because this red line has the same slope but a different y-intercept. The equation for this line would read y equals negative 3/4 x plus 1. This equation has the same slope but a different y-intercept. C. Write a second equation whose graph goes through ordered pair 0, 2, so the system has one solution at ordered pair 4, 1. This red line intercepts y at 2. The slope for the red line is negative 1/4. So the equation for the red line is y equals negative 1/4 x plus 2. Number 2. Create a second equation so the system has no solutions. In order for two lines not to share any solutions, both lines should never intersect. Therefore, they should have the same slope and different y-intercepts. So the new equation is y equals 3/4 x minus 1. It has the same slope, but a different y-intercept. You can write the equation as y equals 3/4 x plus 1 if you want, as long as the y-intercept is different. What needs to be the same is the slope. So y equals 3/4 x has to be the same. It's the y-intercept, or in this case, the last term, that needs to be different than the original one. Number 3. Andre is in charge of cooking broccoli and zucchini for a large group. He has to spend all $17 he has and carry 10 pounds of veggies. Zucchini costs $1.50 per pound and broccoli costs $2 per pound. One graph shows combinations of zucchini and broccoli that weigh 10 pounds, and the other shows combinations of zucchini and broccoli that costs $17. The black line graph shows the 10-pound combination of zucchini and broccoli, and the bluish line graph shows the combination of $17 worth of zucchini and broccoli. A. Name one combination of veggies that weighs 10 pounds but does not cost $17. This sounds harder than it looks. Really, we're just looking for a point on the black graph that's not on the blue graph, because the black graph represents a combination of 10 pounds of zucchini and broccoli, and the blue graph represents $17 worth of zucchini and broccoli. I'll select the point that represents 5 pounds of zucchini and 5 pounds of broccoli. That's close to the blue line, but not on the blue line. B. Name one combination of veggies that costs $17 but does not weigh 10 pounds. Now we need to find a point on the blue line that's not on the black line. I think I'll go with 10 pounds of zucchini and 1 pound of broccoli. That point falls on the blue line, but not on the black line. C. How many pounds each of zucchini and broccoli can Andre get so that he spends all $17 and gets 10 pounds of veggies? This is going to be the point where the two lines intersect. So the only point I can select is 6 pounds of zucchini and 4 pounds of broccoli. Number 4. The temperature in degrees Fahrenheit, F, is related to the temperature in degrees Celsius, C, by the equation F equals 9/5 C plus 32. A. In the Sahara Desert, temperatures often reach 50 degrees Celsius. How many degrees Fahrenheit is this? The temperature mentioned in that desert is 50 degrees Celsius, so I need to substitute the C with the value of 50. Now the equation reads F equals 9/5 times 50 plus 32. In this case, we can cross cancel. 5 goes into 50 10 times, and 5 goes into 5 once. Now the equation reads f equals 9 over 1 times 10 over 1 plus 32. And that's the same as f equals 9 times 10 plus 32. So f equals 9 times 10, which is 90, plus 32. So the degrees in Fahrenheit equals 90 plus 32, which is 122 degrees Fahrenheit. So when the desert is 50 degrees Celsius, it's also 122 degrees Fahrenheit. B. In parts of Alaska, the temperature can reach negative 60 degrees Fahrenheit. How many degrees Celsius is this? Since the temperature in Fahrenheit is negative 60 degrees, we need to substitute the F with a negative 60. Now the equation reads negative 60 equals 9/5 C plus 32. Let's take away 32 from both sides of this equation. 32 minus 32 cancels each other out, and negative 60 plus a negative 32 equals negative 92. Now the equation reads negative 92 equals 9/5 C plus 0, or negative 92 equals 9/5 C. To get the C by itself and make it just 1 C, we need to multiply by the reciprocal of 9/5. So we're going to multiply both sides by 5/9. That leaves us with just 1 C all by itself on the right side of the equal sign, and negative 92 times 5/9 on the left side of the equal sign. That becomes 460 over 9 equals 1 C, which is equal to 51 1/9. So in this case, negative 60 degrees Fahrenheit is equal to 51 1/9 degrees Celsius. C. There is one temperature where the degrees Fahrenheit and degrees Celsius are the same, so that C equals F. Use the expression from the equation where F is expressed in terms of C to solve for this temperature. Look in the middle of this paragraph. In the middle of the paragraph, it says that C equals F. So in this case, C can equal F. Now focus your attention on the two equations in the lower left side of the screen. I have F equals 9/5 C plus 32. But then since C equals F, I can substitute that F with the C. So let's look at the bottom equation. It says C equals 9/5 C plus 32. Now the situation in the paragraph says that C equals F. Since C equals F, these two equations are virtually the same. When we solve for C in this bottom equation, we're also solving for F. Here we go. Let's collect like terms. The C on the left is 1C, which is equivalent to 5 over 5C, or 5/5 C. Now we can collect those like terms. Let's subtract 9/5 from both sides. Now on the left side, we're left with negative 4/5 C, and on the right side, we have 32. To make this a positive 1C, we'll have to multiply by the reciprocal of negative 4/5. So let's multiply both sides by negative 5/4. I've discovered that C equals negative 40. But remember, in this case, C equals F. So F also equals negative 40. Negative 40 degrees Fahrenheit and negative 40 degrees Celsius are equal temperatures.
8th grade, Unit 4, Lesson 13, Solving Systems of Equations. Problem number 1. A. Write equations for the lines shown. Let's start with a black line first. In order to write an equation for this line, we need to find the y-intercept and we need to find the slope. It looks like this black line goes through the y-axis right at positive 2. So the y-intercept is positive 2. And if we were to go up 3 units and to the right 1 unit, we can identify the slope. So the slope is 3 over 1 and the y-intercept is 2. The equation is y equals 3x plus 2. Now let's take a look at the blue line. It looks like the blue line intersects the y-axis at 8 and the slope is down 3 and to the right 1. So it has a negative 3 slope and a y-intercept of 8.
The equation for the blue line is y equals negative 3x plus 8. B. Describe how to find the solution to the corresponding system by looking at the graph. The solution is the point where the two lines cross. The solution for the system is the point 1 and 5 where the lines meet. C. Describe how to find the solution to the corresponding system by using the equations. Since the two equations are equal to each other, set the two expressions to equal each other and solve for x. After you find the value of x, plug it into one of the original equations and solve for y. Problem number 2. The solution to a system of equations is the ordered pair 5 and negative 19. Choose two equations that might make up the system. The 5 is the x value, and the negative 19 is the y value. So we can plug in the value for x and plug in the value for y. Here I've substituted the y with the negative 19 and substituted the x with a 5. Negative 19 equals negative 3 times 5 minus 6, or negative 19 equals negative 15 minus 6. Negative 19 does not equal negative 21. This equation does not make up the system. B. Substitute the y with the negative 19 and substitute the x with a 5. Now the equation reads negative 19 equals 10 minus 23. And negative 19 does not equal negative 13. So this equation does not make up the system. C. Again, we're going to substitute the negative 19 for y and substitute 5 for x. Negative 19 equals negative 35 plus 16. Negative 19 equals negative 19. Yes, this equation does make up the system. D. Substitute y with negative 19 and x with 5. Negative 19 is not equal to negative 12. So no, D does not make up the system. E. Substitute the y with the negative 19 and substitute the x with a 5. Negative 19 equals negative 10 minus 9. Yes, negative 19 does equal negative 19, so E is an equation that makes up the system. Problem number 3. Solve the system of equations. Y equals 4x minus 3 and y equals negative 2x plus 9. Make y equal to y. So now the expressions that are equal to y are equal to each other. Add 2x to both sides. 4x plus 2x is 6x, and negative 2x plus 2x cancels each other out. Add 3 to both sides. Negative 3 plus 3 cancels each other out, and 9 plus 3 is 12. Divide both sides by 6. 6x divided by 6 is x, and 12 divided by 6 is 2. X equals 2. Substitute the x with a 2, and you have y equals 4 times 2 minus 3. Y equals 8 minus 3. Y equals 5. So we know the value for y is 5, and the value for x is 2. So the solution for the system of equations is 2 and 5. Problem number 4. Solve the system of equations. Y equals 5/4 x minus 2, and y equals negative 1/4 x plus 19. Let's make y equal y. Again, the expressions will equal one another. Add 1/4 x to both sides. Add 2 to both sides. Multiply both sides by 4/6, and x equals 14. Substitute the x with the 14, and you have y equals negative 1/4 times 14 plus 19. Y equals negative 14/4 plus 19. That's equivalent to y equals negative 7/2 plus 19 over 1. Since we're going to add these fractions, we need common denominators. 19 times 2 and 1 times 2. Now the equation reads y equals negative 7 halves plus 38 halves, which is equivalent to y equals 31 halves. So y equals 15 and a half. The solution for this system of equation is 14 and 15 and a half. Problem number 5 from 8th grade, Unit 4, Lesson 6. Here is an equation. A. Solve the equation by using the distributive property first. Using the distributive property first, we can rewrite this equation. We have 15 times x, and we have 15 times minus 3, so that's going to be a 15x minus 45, and that's over 5. And we have a 3 times 2x, and a 3 times a negative 3. That's 6x minus 9. Now we need to multiply both sides by 5. Now the equation reads 15x minus 45 equals 30x minus 45. Next we need to add 45 to both sides. That leaves us with 15x equals 30x. We have to subtract 30x from both sides, and we have negative 15x equals 0. Divide both sides by negative 15, and we have x equals 0. B. Solve the equation without using the distributive property. Multiply both sides by 5. Now the equation reads 15 times x minus 3 equals 15 times 2x minus 3. Divide both sides by 15. Now the equation reads x minus 3 equals 2x minus 3. Add 3 to both sides, and the equation reads x equals 2x. Subtract 2x from both sides, and we have negative 1x equals 0. Divide both sides by negative 1, and x equals 0. C. Check your solution. Substitute the x with a 0. 15 times 0 minus 3 over 5 equals 3 times 2 times 0 minus 3. Multiply both sides by 5. Now we have 15 times 0 minus 3 equals 15 times 2 times 0 minus 3. Divide both sides by 15. 0 minus 3 equals 2 times 0 minus 3. Negative 3 equals 0 minus 3. Yes, that's true. Negative 3 equals 0 minus 3. Therefore, the solution, x equals 0, is correct. 8th grade, Unit 4, Lesson 14, Solving More Systems. Problem number 1, solve. It tells you that y equals 6x, so you can substitute this y with 6x. Now the equation reads 4x plus 6x equals 7. Now we can combine like terms. 4x plus 6x equals 10x. Let's find out how much the value is for 1x. We'll do that by dividing both sides by 10. 10x divided by 10 is x, and 7 divided by 10 is 7/10. So x equals 7/10. Now we can solve for y by substituting the x with 7/10. Y equals 6 times 7/10. 6 times 7/10 equals 42/10. So y equals 42/10, or y equals 4.2. We figured out that x equals 7/10 and y equals 4 2/10. Therefore, the solution for the system of equation is 7/10 and 4 2/10. Problem number 2, solve. Y equals 3x. We can substitute the y with the 3x. Now the equation reads x equals negative 2 times 3x plus 70. Negative 2 times 3x is negative 6x. X equals negative 6x plus 70. Let's add 6x to both sides. Now we have 7x equals 0 plus 70, or 7x equals 70. Let's divide both sides by 7. 7x divided by 7 is 1x, or x, and 70 divided by 7 is 10. So x equals 10. Now we can substitute the x with a 10. Y equals 3 times 10. Y equals 30. X equals 10 and y equals 30. The solution for the system of equations is 10 and 30. Problem number 3. Which equation, together with y equals negative 1.5x plus 3, makes a system with one solution? Equation A has the same slope and different y-intercept. Therefore, the lines of these two equations will never intersect. They will share no solution since they are parallel lines. Equation B also has the same slope and different y-intercept. Therefore, the lines of these two equations will never intersect. They will share no solution since they are parallel lines. Divide all the terms on both sides of the equal sign by 2. And now the equation reads y equals negative 1.5x plus 3. Equation C has the same slope and the same y-intercept. Therefore, the lines of these two equations are the same line. They will share infinitely many solutions, not just one. Subtract 3x from both sides of the equal sign for equation D, and the equation now reads 2y equals negative 3x plus 6. Divide all the terms by 2, and now the equation reads y equals negative 1.5x plus 3. Equation D has the same slope and the same y-intercept. Therefore, these two lines are also the same line, and they too will share infinitely many solutions, not just one. Equation E. Y equals negative 2x plus 3. The slope is different than the original equation, but the y-intercept is the same. Both equations will form different lines, but they will cross at the y-intercept 0, 3 because they have the same y-intercept. Equation E will share one solution with the equation y equals 1.5x plus 3. Problem number 4. The system x minus 6y equals 4 and 3x minus 18y equals 4 has no solution. First, I'd like to rewrite these equations in slope-intercept form so you can see why this system has no solution. After subtracting x from both sides on the equation on the left and subtracting 3x from both sides on the equation from the right, we need to divide both sides by negative 6 for the equation on the left and divide both sides by negative 18 for the equation on the right. Now we have both of the equations written in slope-intercept form. We can see that they have the same slope and different y-intercept. These two equations have the same slope and different y-intercept. Therefore, the two lines will never cross. They are parallel lines. A. Change one constant or coefficient to make a new system with one solution. I will change the first coefficient of x in the first equation to negative 1. This way I will end up with different slopes and different y-intercepts, and the two lines will cross at some point. Let's write it in slope-intercept form by adding x to both sides. Divide both sides by negative 6, and we can rearrange the order of the right side to make it slope-intercept form. This equation reads y equals 1/6 x minus 2/3. And you can see the slope is 1/6 and the y-intercept is negative 2/3. Different slopes and different y-intercepts, and the two lines will cross at one point. B. Change one constant or coefficient to make a new system with an infinite number of solutions. Change the second equation to 3x minus 18y equals 12. This equation has the same slope and the same y-intercept. The two equations will share infinitely many solutions. Problem number 5. From from 8th grade, Unit 3, Lesson 11. Match each graph to its equation. Graph A has a y-intercept of 3 and a slope of down 4 and to the left 2. So that would be a slope of 2. So we need to look for an equation that has a slope of 2 and a y-intercept of 3. That would be number 1. Graph A matches with equation number 1. Graph B has a y-intercept of -3, and the slope has a rise of 2 and a run of 1, which is a slope of 2. We need to find an equation that has a slope of 2 and a y-intercept of -3. And that would be equation number 3. Equation number 3 matches with graph B. Graph C has a y-intercept of 3 and a slope that has a rise of -2 and a run of +1. That would be a -2 slope. So we need to find an equation that has a -2 slope and a y-intercept of 3. And that would be equation number 2. Graph C matches with equation number 2. Graph D has a y-intercept of -3 and a -2 slope. Graph D matches with equation 4. Problem number 6 from 8th grade, Unit 3, Lesson 10. Here are 2 points, -3 and 4, and 1 and 7. What is the slope of the line between them? Remember, the slope is the difference between y1 and y2 over x1 and x2. So let's substitute 4 and 7 to represent y1 minus y2, and -3 and 1 to represent x1 and x2. So 4 minus 7 is -3, and -3 minus 1 is -4. -3 over -4 is equivalent to 3/4. So the slope is B, 3/4. 8th grade, Unit 4, Lesson 15, Writing Systems of Equations. Problem number 1. Kieran and his cousin worked during the summer for a landscaping company. Kieran's cousin has been working for the company longer, so his pay is 30% more than Kieran's. Last week his cousin worked 27 hours and Kieran worked 23 hours. Together they earned $493.85. What is Kieran's hourly pay? We can set it up like this. Let K equal Kieran's hourly wage and let C equal Kieran's cousin's hourly wage. Since Kieran's cousin makes 30% more than Kieran, we can write the first equation as C equals 1.3 times K. This represents 100% of what Kieran earns and 30% of what Kieran earns. The second equation is 27C plus 23K equals 493.85. 27C stands for 27 hours that Kieran's cousin worked, and 23K represents the 23 hours that Kieran worked. The 493.85 represents the $493.85 that they earned together. Now substitute the value of C into the second equation. We determined that C equaled 1.3K, so we can substitute the C with a 1.3K. 27 times 1.3K equals 35.1K. Next, we combine like terms. 35.1K plus 23K equals 58.1K. Divide both sides by 58.1, and Kieran makes $8.50 an hour. Problem number 2. Decide which story can be represented by the system of equations. Y equals x plus 6 and x plus y equals 100. Explain your reasoning. A. Diego's teacher writes a test worth 100 points. There are 6 more multiple choice questions than short answer questions. In this story, y equals x plus 6 can be written where x and y represent the number of questions of each type. However, in the second equation, it doesn't make sense because x and y represent points. Let's look at story B. Lynn and her younger cousin measure their heights. They notice that Lynn is 6 inches taller and their heights add up to exactly 100 inches. In this story, it makes sense that y represents Lynn's height and x represents the younger cousin's height. I would select story B. Problem number 3. Claire and Noah play a game in which they earn the same number of points for each goal and lose the same number of points for each penalty. Claire makes 6 goals and 3 penalties, ending the game with 6 points. Noah earns 8 goals and 9 penalties and ends the game with negative 22 points. A. Write a system of equations that describes Claire and Noah's outcomes. Use x to represent the number of points for a goal and y to represent the number of points for a penalty. Here's Claire's equation. 6g plus 3p equals 6. The 6g represents the 6 goals she scored, 3p represents her 3 penalties, and 6 represents the points she ends the game with. Here's a look at Claire's equation using x for goals and y for penalties. Here's Noah's equation. 8g plus 9p equals negative 22. 8g represents his 8 goals, 9p represents his 9 penalties, and negative 22 represents the number of points he ended the game with. Here's a look at Noah's equation using x for goals and y for penalties. B. Solve the system. What does your solution mean? We can start with Claire's equation. Let's subtract 6x from both sides. Divide both sides of the equal sign by 3. Now that we know that y equals 2 minus 2x, we can substitute the y with a 2 minus 2x in Noah's equation. Now his equation reads 8x plus 9 times 2 minus 2x equals negative 22. Use the distributive property to multiply 9 times 2 and 9 times negative 2x. Combine like terms. Subtract 18 from both sides of the equal sign. Divide both sides by negative 10. And we discover that 1x equals 4. So now we can substitute the x in Claire's equation with a 4. Now the equation reads y equals 2 minus 2 times 4, or y equals 2 minus 8. And now we know that y equals negative 6. The solution for the system is x value 4 and y value negative 6. And this means that each goal is worth 4 points and each penalty is worth negative 6 points. Problem number 4 from 8th grade Unit 4, Lesson 14. Solve y equals 6x minus 8 and y equals negative 3x plus 10. This tells us that 6x minus 8 equals negative 3x plus 10. Let's start solving by adding 3x to both sides of the equal sign. Now we have 9x minus 8 equals 10. Next, let's add 8 to both sides of the equal sign. Now we have 9x equals 18. Divide both sides by 9, and we have x equals 2. Now that we know the value for x is 2, we can substitute the x with a 2 in this equation. Now it reads y equals 6 times 2 minus 8. 6 times 2 is 12, so now we have y equals 12 minus 8. 12 minus 8 is 4, so we have y equals 4. The solution for this system of equation is x value 2 and y value 4. Problem number 5 from 8th grade Unit 4, Lesson 13. A. Estimate the coordinates of the point where the two lines meet. You can see where the two lines meet, and if you look down to the x-axis, it looks like it's a little bit more than 1.5, maybe 1 3/4 or 1.75. And if you look along the y-axis, it looks a little bit less than 1.5, perhaps 1.4. So my guess would be 1.75 for the x value and 1.4 for the y value. B. Choose two equations that make up the system represented by the graph. It looks to me like the y-intercept is at the origin, so the y-intercept would be 0. So we need to find an equation that would have the y-intercept as 0, and it looks to me like the slope is up 4 and to the right 5. So that would be a rise over run of 4 over 5, which is the same thing as a slope of 8/10. So let's look at equation 5. Y equals 8/10 x, and then if we added a plus 0, that would be the y-intercept. So I would go with equation 5. For this line, we have a y-intercept of 6, and the slope goes down 5 and to the right 2. So that would be a negative 5/2 slope. And negative 5/2 equals negative 2.5. So the slope could be negative 2.5, which is the same as negative 2.5. This matches up perfectly with equation number 2. Y equals 6 minus 2.5x. The 6 would be the y-intercept, and the minus 2.5 would be the slope. Let's use those two equations as a system of equations. And we can substitute the 0.8x for the y. So the second equation would read 0.8x equals 6 minus 2.5x. Add 2.5x to both sides. Divide both sides by 3.3. And 1x equals 1.81. Now we get to substitute the x in the other equation with a 1.81. So it reads y equals 0.8 times 1.81. Y equals 1.45, or 1 45/100. The accurate answer is x value 1.81 and y value 1.45. I think our estimate is pretty close. My estimate was 1.75 for the x value and 1.4 for the y value.